Okay. Is this working? All right. So here's what we're going to do today. We are going to figure out how to take arbitrary code and run it from inside Lua. So our goal will be to write, some function. So like we'll open up a Lua. That's right. Okay, I got to back up a little bit here. First, we need to install Lua. If you are on a Linux system, you can do sudo, yum or apt or whatever, install thing. In Replit, they have this really nice system here, which has something to do with this nix that I don't exactly know what it is. Need to get the exact package name. Yeah, it is 5_4. So here, if you go, so I guess it's just a general thing about Replit or any system that uses this nix thing, whatever that is. You can look up the packages here on this search.nixos.org/packages, and we can find Lua. Another one that we're probably going to use is this RL wrap, which is really nice. So let's put that in there. And let's just put in a few that I like to use in case we need them. That should be enough for now. So now if we do this, which Lua, fine. Now, hopefully, now that Lua is installed, we should be able to find the Lua headers. We can hide the hidden files now, we don't need them. Okay, great. So because we installed Lua, the header files for Lua ended up in the standard, include directory. So we didn't have to do anything special. There is another option, which I will show you, and there is a reason why you might want to do this. It will make it easier to single-step code when you're debugging it and trying to figure out why Lua is doing something weird. So what you're going to want to do is download Lua. So if you go to this Lua download page, here's the link, curl, whatever. So let me just go in here and do that. Okay, I don't need the GZ file. And here's all the source code to Lua. And I really got to give the Lua folks credit. I mean, it's so easy to use Lua for everything, and it's a great language. So it is my favorite programming language. And the reason I'm doing this tutorial on Lua plugins is because there are some things that are kind of hard to do in Lua, and although you can get decent performance, you're never going to get the same performance as C or C++. But C or C++ is really painful and unfriendly to use. So this is kind of like the best of both worlds, in a sense. So anyway, where was I? What we want to do is we want to actually build Lua. Now, one thing that I'm going to do, this is, I think if you do my C flags equals -G-O0 make. Did that work? No, it didn't. It's still using O2. Well, there's another option here. You can just go into the makefile inside source and just edit it directly, which is what I normally do because it's pretty foolproof. I'm just going to go in here in this C flags, and I'm going to change this to -G-O0. I'm also going to put -G in the linker flags just in case that matters. So let's make clean and then make it again. So we get this warning here that you need optimizations turned on to use this fortify source. I have no idea why, but that's harmless. I really don't care about that. Well, okay. Just in case someone's watching and is just going to blindly follow every word I say, it is not actually okay to just ignore this fortify source. This fortify source reduces a lot of vulnerabilities in the standard C library. So you really do want to have it turned on. I just don't care on this replit on this project. Fine. Now, let's go into this replit.nix and actually get rid of Lua, just so that I can show you what it looks like to compile against a manually built Lua from source. By the way, I've downloaded a lot of stuff and tried to make it using the provided makefiles. Never does it ever work flawlessly every single time without fail, except for Lua. It's great. You just type make and that's it. You know. But anyway, I'm getting off track. The other thing we need to do here, although that did build everything, it made all these .o files and it made the, liblua, where is it? It's in here somewhere. Liblua.a, the static library. It built all that stuff, but it's kind of in an annoying place. So if you do make local, it will copy all the stuff into a handy install folder here, and it even puts the compiled Lua interpreter inside bin. So let's see. Now if I do which Lua, it should say no such thing. And if I go here and try and compile this, it should say can't find the header. Yeah, because I don't have Lua installed. So now let's tell this thing where to get the Lua header. I guess we'll go into the makefile for this replit project. And for CXX flags, we'll just add this -i here. So notice where it's using this TXX flags. It's when it compiles the .o files for every CPP file. So we'll just include this Lua 5.4.4/install/include. We don't actually need to edit the linker flags at all. And, oh, actually, let's put O0 so that we can single step our own code nicely. We don't care about performance here today. Where's the linker flags? Oh, it uses the same CXX flags, okay. We don't need to edit the linker flags, so we don't have to do -l Lua or -L for it to find this Lua install lib folder. I mean, it does put it there, but our end goal here is we're going to compile this file into a shared object. And then the Lua interpreter, to be precise, one of the built-in functions of Lua will load that shared object. And when it does so, all of the undefined symbols to the Lua functions that we need to call will be resolved. So we don't actually need to care about linking our code against the Lua stuff. We really just need this header file. Okay, great. So let's do a hello world. And hello world. Now, if you want to write a function that Lua is able to call, it needs to have this prototype. It has to return an int to say how many values the function returned. And it takes this Lua state type as an argument. And this is how you will access the function call arguments, and it's where you will put the return values that the Lua interpreter will use. For now, let's just have it print out hello Lua. Okay. Now, I guess we'll just compile it on the command line for now. I might make a nice shell script for it later, but let's get this thing out of here. So if I do this, oh yeah, this right, because it doesn't have a main function, and this, well, so we have two options. We can either edit the replit makefile to produce the right thing, or we can do it on the command line. We'll just do it on the command line for now. So we want to do g++ -shared, because we want a shared object. -o, we'll call it, I don't know, thing.so. It'll take name.cpp as argument. Oh, right. I went to all that trouble to edit the makefile to go to this path, but and if I'm just doing it on the command line, that doesn't matter. So Lua 5.4.4 include install include. No return statement. Oh yeah, okay. We should tell it to return 0 to say that we returned no values. Now, here's what we are going to do. So which Lua. Okay, so let's just do alias Lua equals 544 install bin Lua. That still shouldn't work, but if I do Lua, okay, great, we're in. And we're going to do an extra thing here. We're also going to do, this is just to make my life easier. We're going to do alias Lua equals RL wrap. RL wrap, I guess I should tell you what it does. If you give it a command, so I'm just going to do, I guess, for install bin Lua. If you give it a command, it will run it, but it will give you readline support for the input, which is really nice. So I think if I just type Lua, great. So now what we want to do is we want to load this function into Lua. How do you do that? Well, there's this function called package.loadlib. You have to point it to your compiled object file, and you have to give it the name of the function that you want. Now, this isn't going to work. It's nil. Why is that? I guess what we could have done, just a nice little thing about Lua here. Cannot open shared object file. No such file or directory. Oh, that's strange. Maybe you need to do this. Okay, so check this out. Undefined symbol, hello world. What do you mean, undefined symbol? It's right here. Okay, well, the experienced C++ people already know what the problem is, but let's see how you could find out what the problem is without having to know what it is already. You might think, okay, well, undefined symbol, let's just see what symbols are defined by this thing.so. So a command you can use for that is nm. So thing.so, and we look through it, and we see some random stuff we don't care about, and we see, oh, what's this? Z10 hello world P9 Lua state. Aha, we are subject to C++ name mangling. Now, let's just prove that to ourselves. Online demangler. Punch this in. There you go. This is the symbol. Fine. One thing that, actually, I've never tried this before, but let's try, instead of punching in hello world, let's try copying this thing that we got from there. Hey, cool. So now if we call the function, hey, great. Well, another way we could solve this problem would be to compile this. You can do this bizarre, like, I don't know who came up with this syntax. It's the most awful, like, I don't understand. It's so complicated and specific. But anyway, if you put extrinc before a function definition, it tells the compiler, hey, don't mangle this name. So now if we recompile that, oh, did I do it in this one? And now if we do nm thing.so, there it is, plain as day, unmangled, hello world. And now if we go back into Lua, we can go in here and just do that. Bam, great. So that's nice, but how do we pass, arguments into this function? We called it and we gave it arguments, but just, it ignored them. This is where we need to understand the concept of the stack. This Lua state among other things, maintains an internal stack of all of the function arguments, and it's also where you will put the return values. And you return it in to say how many values you pushed onto this stack. Now, this is a little odd, but unlike, if you're familiar with the stack in C programming, this stack isn't the stack of all nested function calls up until this point. It's actually just the stack for this one function call. And even stranger, when you return values, the reason you have to return this int to say how many values you returned, it's because, can I do this? You can add a drawing to these things, like, forget how you do it. Oh, here we go, drawing, okay. So sketch.draw. So inside this Lua state, Replit rules, by the way. I love Replit. How do you change the, whatever, it's just going to be this bizarre font. Inside here we have this, I guess it's called the stack. I put the stack in quotes here because you're not restricted to just a normal last in, first out. You can actually access arbitrary elements of the stack. Now, let's start by just printing how many elements are in the stack. The way you do that is you say, you give me %d arguments. And there's this function here called Lua get top. Oops. Now, Lua get top, well, it just, so this stack is automatically sized for the number of things in there. And Lua get top tells you the index of the top element. Now, for whatever reason, this stack is indexed using one indexing. So this is element 1, 2, 3, 4. Okay, I admit this doesn't look that nice, but you get the idea. Okay, great, so let's recompile that. Okay, and now let's load our function. We can call our function. You gave me 0 arguments, and then if we call it with arguments, you gave me 4 arguments. Great, we are making moves. Now, before I talk about how to access these arguments, let's talk about how you can return values. The strange thing about Lua, well, it's not really a strange thing about Lua, it's just, if you want to return values, you don't actually have to pop these elements. You can just put your values on the end here, as many as you want, and just tell Lua how many you pushed on here. And the reason you return the int is to tell Lua, okay, only the top, this many elements are on the stack, or are my return values. And then Lua will take care of like deleting all this stuff and only returning the stuff you returned. So let's do an example of that. Let's do, I was looking this up earlier, this Lua push string. Oh, just so you know, this is the Lua manual. It's very good. Okay, so Lua push string, you give it the state pointer here, and you give it a string there. Pushes the 0 terminated string pointed to by s onto the stack. Lua will make or reuse an internal copy of the given string, so the memory at s can be freed or reused immediately. Okay, great. So here's what we're going to do. We'll do char line a like this, and we will actually sprintf this message into it. And then I lost connection, but that's okay, the connection's back. So I don't know how much was lost there, but we're using this Lua push string. It makes a copy of the string you gave it. It assumes that it's zero terminated, and it pushes it onto the stack. So what we have going on here is, in this example here where we called it with 1, 2, Kevin, nil, we have 1. Oh my goodness. All right. We can do a little better than that. I don't know how useful it is for me to actually draw this whole thing here, but so that's what the stack looks like by the time we get into this function. Now, if I push a string here, we're going to print it to, or we're going to push it to this Lua state, and we'll give it this line that we just made, and we return 1 value. What happens here is that your function pushed this string and so this might seem like the function is returning 5 elements. No, what happens is because you returned this integer, it tells Lua, hey, I really only care about the top 1 element of the stack. Just delete all this other stuff and return only this. So that's what this return value means. You don't even have to pop the other stuff. Okay, so let's do that. So if I call the function, it looks the same. It's returning it as a string though, it's not just printing it with putS. So if I do this, I print the string, there we go, you gave me 0 arguments. And if I do stir equals function of 1, 2, Kevin, nil, print the string, you gave me 4 arguments. Great. The next thing we want to do is, well, how do we actually get access to these arguments? Well, the way you do that is with there's 2 options here. There's Lua to string, for example. There's Lua to, there's a whole bunch of them here. So there's Lua to pointer, to string, to number, to else string, to integer. There's a whole bunch of these. So what's going on here? Well, the thing that's going on is each of these elements in the stack is actually like a C union with like an integer that says what type it has. Now, to see the list of types in Lua, you can just search this manual here. There's a list of types. There's type for nil, number, boolean, string, etc. So what we're going to do is this, just as an example. We will do, well, let's just leave that the way it is. So we'll get the number of arguments. Now, remember that in Lua, the stack is 1 indexed, just like everything else in Lua. So we're going to use this new function here. So here, let's do this. For int I equals 1 is less than or equal to args plus, and we will do printf argument %d has type %s. And here we'll do Lua type li. Now, unlike a stack, you can just access elements at any arbitrary index that you want. So that's what this I here is. Now, this Lua type function doesn't return a string. It returns an int. So what we're going to do is we're just going to do this tnames is equal to, and what we'll do is we will open Lua lua.h. This is just, for pretty printing. I don't know how useful this is here, but why not? It might be useful for debugging. I always forget how to do this. There we go. No. Okay. There's got to be an easier way, but I don't know what it is. Just do this manually. And here we'll just do t names of that. Okay, great. Oh, I didn't mean to do that. %d, oh yeah, I forgot to put I. Okay. Where is that? Okay, so if I call it with no arguments, it returns you gave me 0 arguments. Now if I call it with 1, 2, Kevin, nil, it prints a bunch of stuff. Argument 1 is type lua t string. That can't be right. It's a number, not a string. What the heck's going on here? Oh, I missed a comma, that's why. Okay. There we go. Argument 1 has type number, 2 numbers, argument 3 has type string, argument 4 has type nil. Great. Now let's think of something interesting that we could do. What's something interesting? I'm struggling to think of an example. Well, maybe it would be useful here to show how to do callbacks. And it would also be useful for me to show you how to do this in such a way that you can use require instead of having to call this load lib for every single function, which is kind of tedious. Let's do that first. Now, by reading this manual the other day, I figured out eventually that if you make a function extern and if you call it lua open and then the name of, so I guess we're calling this thing.so for now. If this name matches the name of your shared object, like this, state pointer L, then when you type, oh, I forgot to put extern C. When you type require, so right now if I do t equals require thing, it'll say, I can't do that. You see it's looking for this lua open thing symbol. That's what require does. What it does is it calls this like any regular function. Notice it has the same return and int, take lua state as argument as the other one. Lua will call this function when it loads your library the first time, and this is how you can, do things like, return a table of functions or push stuff into the global variables or whatever. For now, we'll just do put s, thank you for calling require, and we'll say it returns no arguments. So now if I do t equals require thing, well, great, call our function. But now if we type t, it's just you know, true because we were able to, you know, load it. But if we show the return values from this, it just returns true. It doesn't return any functions. Like we can't do anything. We can't call hello world, for example. It just doesn't exist. So what do we do? Well, option one is to just push this function into the global variables, which we could certainly do. Let's do that as an example. I believe the function is called setGlobal. Yes, let's look at the real documentation here for it. Pops a value from the stack and sets it as the new value of global name. Okay, so let's do Lua push, I think it is push C function. Pushes a C function onto the stack. Okay. And we will push this. We don't need to put extra C anymore on this. The address of hello world. And then we will do Lua set global L. We'll just do HW for short here. Okay. So now if I do, so if I type HW, it's nil, and if I do require thing, so it returns true because it loaded properly, and I guess for convenience it tells you the file that it got it from. Now if we type HW, it's a function, and we can call it, it's the same function we had before. Great. Still does the, whoops, come on. There, fine, great. Okay. Now the other thing that is typically done here when you load a, you know, when you require something like that, is that you'll actually have it return a table of functions rather than pushing them into the global namespace. Or, well, the other option is that it'll just push everything into a table in the global namespace. So let's do that. Now I need to remember, I think it's Lua new table, yes. Creates a new empty table and pushes it onto the stack. So let's do that. Lua new table. L. Now, I think what we want is the Lua set table. Does the equivalent to t of k equals v, where t is the value at the given index. At the given index. Okay, so remember earlier I said that you don't really have to access the stack, like last in, first out. You can just give arbitrary indices. Well, that's what that index is for. So t of k equals v, where t is the value of the given index, v is the value on the top of the stack, and k is the value just below the top. Okay, so let's push the key. So push string LHW. Then we Lua push C function. Now we'll do Lua set table. So let me put here. Stack equals just the table. Now we have the stack equals the table and the string HW. Now we have the stack equals the table, the string HW, and you know, the function. And then here we will just have the stack is equal to the table where the key hello world is equal to the function. And now what we can do is we can do Lua set global thing. Stack is empty. So let's do that. Invalid conversion. Oh, right. So this is element 1 of the stack, like that. Now this is where we could just use number one. We have another option. In Lua, it's similar, I think JavaScript does this. You can use negative indices for the stack. So this is index 1, 2, 3, 4, 5. But this is also index -1, -2, and so on. It's usually a little bit better to use negative indices because then, if something was on the stack, I mean, there never would be anything, but suppose something was on the stack, then this would still work. So we would do minus, let me think here, -1 would be that, -2 would be that, -3 would be the table. So let's do that. Okay. Now let's do require thing. And now, if I type thing, it's a table. If I do thing.hw, it is that function. Thing.hw does the same thing as before. Okay. Now this looks a little bit tedious to have to do all of this work. So luckily for us, there is a function called Lua L. I don't remember. Is it like open libs? No. Create. No, that's not it. What is it called? They renamed it in Lua 5.3 or 4. New lib. This Lua L new lib creates a new table and registers there the functions in the list L. It is implemented as the following macro. I don't care about that. So you need this array of Lua L reges. Now, let me look at try and find the documentation. So quite simply, this Lua L reg is a struct where you give it the name and a pointer to the function. So if I go back to where we just were, all we want to do is make an array and, well, yeah. So we will do static Lua L reg. Is that the type name? Capital R. L reg. I don't know. My functions is equal to. Now this is something that I read. I forget where. It's somewhere in that programming in Lua, but you have to null terminate this. And then you just put your functions in here. So we'll call this HW, and we'll give it the address to hello world like that. And now here, instead of all of this, we can just do Lua L new lib L and my functions. Pushes. Like that. And great, so this should work. Hello world. Okay, thing.hw, everything still works. Great. What else do we want to do? I could end this, but I feel like doing something interesting. It would be cool. One thing that I wanted to do was to do like a brute force solver for like puzzle games. And it would be nice to be able to do some parts of it in Lua, some parts in C or C++, because, excuse me, you do need speed. Oh, you know what? Let's do a, no, it'd be, well, it'd be nice maybe to have a hash function.
trying to think of a good example.
I mean, it would be nice to write a brute force solver that... Yeah, let's just do it. Let's just do it. But I'll do it in a new stream, so it's a separate video.